Hello everyone, in this video we are going to look at a problem called flatten BST to sorted list, which was given as a problem of the day on 16th February in Geeks for Geeks. You can pause the video and read the problem statement. What it asks us to do is, given a binary search tree, we know that for a BST there exists a unique in-order traversal. So what we need to do is, the final output should be such that when these nodes are arranged in in-order traversal, the right pointer of each node should point to its successor in the in-order traversal for every node. So what you have to do is, without using any extra storage like arrays or vectors, you need to only depend on the recursion and flatten this BST such that you have to return at last the starting node in the in-order traversal. For example, if you look at example 1, this is the original BST. What we did is, we flattened it by changing the right pointer of node 2 to 3, which is the in-order successor of node 2, and we made the right pointer of 3 point to node 4, and we made the right pointer of node 4 point to node 5. This is nothing but the in-order traversal of the tree, but here we need to traverse the tree and consecutively change the pointers instead of just printing the in-order traversal. This question is quite different from printing the in-order traversal. And also it is important that you change the left pointer of every node in the tree to null. So let's see how we can proceed. So as we know that the final order in which the nodes will be arranged are in order. So what we do in the in order is, we explore the left subtree and then we come to current node, which is like root, and then we explore the right subtree. So for exploring the right subtree, we just make a recursive call to the left child of the current node. Before that, we need to make sure that the root is not null. If it is null, we just return null. We don't have to do anything. As I said earlier, we need to know the starting node of the in-order traversal. Before that, whenever a current node is explored, we need to capture that node. For that, we use a global variable called previous, which is initially assigned to null. When this, I will explain this later. Before that, suppose after exploring the left subtree, the previous pointer should indicate the last node that has been explored in the left subtree in the in-order traversal. That is, for example, the current node is 5, then the last node that will be explored in the left subtree is 4. That is the one that comes before 5. So that's what previous pointer actually points to. What we do is, if previous is not null, we will make sure that the right pointer of this previous, that is the right pointer of 4th node, will point to 5. We should also make sure that its left pointer has to be null. And the important thing is, we also have to capture the first node that comes in the in-order traversal. So the first node comes when the previous pointer gets its first value. So before it gets its first value, when that is the first node that is explored in the in-order traversal, let's declare another pointer start that points to the start of the in-order traversal. So what it means is, when the previous pointer is initialized with a non-null value for the first time, we are capturing it as the start node. That's what it means. Now that you have you took care of the left subtree, now the previous is root, and after that right subtree needs to be explored. Now after all the nodes are explored, what we need to do is the last node that comes in the in-order traversal, its right pointer should be null and also its left pointer has to be null. And making the left pointer null is taken care here. But making the right pointer null is not taken care, so it needs to be taken care here. Finally, we return the start. Oh, make sure that the left pointer should also be null, because take the last node, for example here for 8, when you are at 7 you are changing the right pointer of 7 to 8. When you are at 8, you should also make sure that the left pointer of 8 is also null. And I think we don't have to consider this condition. It worked.